Hi everyone. Thanks for coming, and thank you for letting me do this in my native tongue, English. I don't speak Polish, so it would be a very short presentation if I had to do it in Polish. So thank you very much for allowing me to do that. I have a few topics I want to talk through. I want to talk through obviously Spring and Kubernetes are the main ones. So just to get a gauge of where the audience is at, who here is already familiar with Docker? Who has used Docker, Docker run, Docker build? Most of us, that's good. I can skip a bunch of slides about Docker. What about Kubernetes? Who is using Kubernetes? Who has used Kubernetes? Less people. Anyone running Kubernetes in production? All right, well, there's two of us, nice. So I will skip through some Docker bits. I'll spend a bit of extra time on the Kubernetes stuff. And then, depending on how much time we have, I also have a recorded demo of like a full CI/CD pipeline of a Spring app through Kubernetes. So we'll see how we go. So this is me. I'm a developer advocate at Pivotal. And I'm unusual in my team in that I'm not actually traditionally a developer. I came from an operations background. So you might call me a DevOps, or if you really didn't like me, you might call me an SRE. But I'm sort of on the Spring team, on the developer advocacy team, and I have a focus on Kubernetes. So I work a lot in the upstream Kubernetes community, and then I work with the Spring team to help figure out how we can better run Java applications in Kubernetes. This is my actual full last name, and I really enjoy coming to Poland because it is the only place where everyone can pronounce my name instead of just me. And in fact, many people in Poland will correct me when I say my own name, because apparently I don't even say it right. So there's that. So Kubernetes, my friend Corey Quinn, who if you don't follow him on Twitter, you should. He is quite funny. He sort of says Kubernetes is named after the Greek god of spending money on cloud services. And that is completely true. There is a reason Google wants you using Kubernetes. There's a reason Amazon wants you using Kubernetes. And that is because it is very easy to have very large infrastructure builds in the cloud. It's not unusual for me to accidentally realize I've got like 40 or 50 load balancers running because I've had all of these test applications. So if you're paying your own cloud bill, you want to be very careful when you're playing around with Kubernetes. Other folks like Kelsey Hightower. So if you're doing a presentation on Kubernetes, you're actually legally required to quote Kelsey Hightower at least once. So I'm getting out of the way. So folks are saying that Kubernetes is a platform for building platforms on top of, meaning from a user perspective, from the developer and user perspective, it's not the easiest way to deploy applications. And so folks like myself in operations, it's our job to bridge that gap and bring a more developer-friendly platform to you. And so when we talk about platforms, we kind of have this paradigm of, on this side we have like traditional hardware where it's all done by people, and the people are kind of the platform, all the way to your application platform like Heroku or Cloud Foundry, the function platforms like Lambda, etc. And there's this kind of, on this side you have a ton of control. If you really care about like the firmware on your SCSI drives, you can care about that, but it's super inefficient. So as you go across to the other side, you lose control. You have to start writing applications in a cloud-centric way. You have to follow the 12 factors, etc. But you gain an immense amount of efficiency. For example, when you're using Cloud Foundry or Heroku, you kind of have a command. Sometimes it's git push, or it might be cf push. But the platform kind of takes care of running your application for you. It takes care of building your application, compiling it into a jar file, and kind of does all of that hard work for you and figures out how to run it. So you don't have to do a ton of work as long as you follow the rules that platform has expected you to develop your software in. With Kubernetes, we have to put a lot more work in. We have to build out that pipeline at the bottom there to actually enable a similar type workflow. So ideally, to the developer, to the end user, you should still have some sort of git push. It magically runs on the cloud, but it's up to us in operations to actually enable that by putting together the CI/CD systems to do that. So we're all familiar with Docker. I can kind of skip through these. When you're building a Docker image, it's pretty important to make them as small as possible, especially if you're planning on running them in Kubernetes, where Kubernetes will often pull and push images as it's repairing applications and stuff. And so the smaller your image, the faster Kubernetes can react to changes, and the more it's able to keep high uptime for your application. So getting to small images is important. Often when you're building an image, you'll do something like this, where you've already built your jar file and you're just copying it into the image. You're using a pretty slim JRE image. You don't need a full JDK to run most Java apps, so you shouldn't put one in the container. Folks like myself, for a long time, I really pushed hard against needing to run Maven or whatever on my laptop. And so I would do this, where I would do the entire thing inside of a Docker image. This is a multi-stage Docker file, so I'm starting from a large Maven, having my install happen, getting my jar package out, copying that into the slim image. And that was great for me because I didn't have to have a bunch of different versions of Java on my laptop, depending on what I was trying to build. But it adds a bunch of time because the moment I do that first copy in the Docker build, Docker image, Docker file, it invalidates all the cache that Docker uses. So this all takes time, and because it's happening inside of a container, I'm not even able to take advantage of my local Maven cache, right? And so doing this build, sure, it was great because I didn't have to have all the Java bits installed, but it would take 10 minutes or more sometimes on a moderately slow internet connection. So what I've kind of come to the realization I do need Java stuff on my laptop. And I've also discovered that there are some tools like Jib, which is from Docker, where you don't actually need Docker installed on your laptop. So if you are hardcore Java dev, you don't even want Docker installed, you don't need it, right? And so when you use Jib, you throw this in your pom.xml, and it will take care of building your Docker image for you. The folks at Google know how a Docker image is constructed, so that's why they can do it without Docker. They just put together the image format in the end. The three ways of building images I've shown will all give you about the same size image for a basic Hello World app, like 200 meg or so, and are all quite good, decent ways of doing it. So whichever way you're comfortable with. I'm starting to really like using Jib because when it comes to my build server, I don't need Docker installed on my build server. And in a larger corporate enterprise, often you have a security team and they get mad when you want to install Docker on random servers. So they quite like this as well. And I can actually quickly show you what that looks like. So this is just a recording of using the Java image builder. And so I go into my app directory and I run a Maven command, and I don't actually even need Jib installed because I can just tell Maven to use Jib like that. And it runs through. It happens really quick because everything is cached in my local Maven. And so it's already finished building my jar, and it's already pushing it up to my Docker registry. So it all happens very quickly. So when I started using this, going from 10 minutes plus to like not even a minute, it was certainly a big improvement for me. So obviously, Docker, you run Docker build, Docker push, Docker run, etc. You're all familiar with those commands. And they're great when you work on your laptop, and they don't scale when it comes time to running things in production. If you have even just a dozen servers and maybe 100 apps in containers or other mediums, you start to need something to orchestrate those things for you. In the past, we would use stuff like Chef and Puppet. Nowadays, we're reaching for Kubernetes. So when you look at Kubernetes, it is a fairly standard platform from a logical perspective. So you have this control plane and a data plane. Obviously, the data plane is where your applications run. And up in the control plane is the Kubernetes itself and the management of Kubernetes and the management of how your applications are deployed. Now, I'm not going to spend too much time on this, but I want to quickly call out the controller manager and the cloud controller manager. They're the things that separate Kubernetes from some of the other container platforms, and are probably why Kubernetes has sort of won that war, and Kubernetes is quickly becoming the de facto standard for a container orchestration tool. And the reason for that is controllers perform this act of, basically when you tell Kubernetes to do something for you, you give it your desired state, and then controllers act upon the actual state and ensure that that actual state meets your desired state. Now, when you're deploying something new to Kubernetes, there is no actual state, so Kubernetes, through controllers, will create the resources that you've requested. And then it will keep an eye on those resources, and if something happens, if there's an error or a failure, it will repair those resources. And so you get this really good, like, fast feedback loop of auto-corrective behaviors that the platform just does for you. Controllers generally follow that Unix philosophy of doing one thing and doing it well. So you can see some controllers are like 100 or less lines of code, and like on your Unix command line, you can pipe commands together. Cat, grep, sed, awk. You can sort of do the same thing with controllers to get complex behaviors from a couple of very simple programs. When you're working with Kubernetes, you will generally use the kubectl command. Some people say kubectl, some people say kubectl. We could get into an hours-long religious debate over that. I don't really care. Say it however you want. There is a dashboard, but generally speaking, you disable the dashboard on your Kubernetes cluster. As Tesla learned, it can often be a vehicle for someone hacking your cluster and running Bitcoin miners. So generally, skip the dashboard and use kubectl. And similar to Docker commands, there are these imperative kubectl commands. Kubectl run, scale, create, where you can tell Kubernetes to do things, but it's very explicit. And this is great for when you're trying some stuff out, when you're doing demos. But when it comes to running things in production, when you want to run something for real, you actually want to use Kubernetes in this declarative mode. In this declarative mode, you provide Kubernetes with your desired state in the form of a manifest, either YAML or JSON, and then kubectl apply sends that up to Kubernetes, and that becomes your desired state inside the cluster. And you have this file that you can then store in source control. You can do Git ops, you can do CI/CD, etc. So it becomes your infrastructure as code for your Kubernetes resources. A manifest looks like this. In its most basic form, it's pretty simple. You have kind of 4 key elements: API version and kind. You have metadata, which is a name, and you would also have labels in there. And then you have your spec, which is effectively the API spec of the resource that you want. And so if I pass this onto Kubernetes, I'll get that application, that Hello World application, running in Kubernetes. There's a couple of different resources I'll talk through. There's a dozen or more resources inside of Kubernetes to do different things. But our 3 basic ones, which you would use to get a fairly simple application running, are pods, services, and volumes. So we'll go through those, and we'll go through those with some demonstration. So a pod is basically the execution environment in which your application runs, right? And so a pod is not a container. A pod is one or more containers that share that execution space. And they share an IP address and localhost, and they share volumes. And so what that allows you to do is, if you have a reason to need more than one container running, say you need a container running to transform a config file before your application actually starts, or say you're running a PHP app, which is 2019, we shouldn't be running PHP apps, but there we are. You might need an Nginx container and a PHP FPM container, and you would have them talk over either a socket on the shared volume or talk over a port on the shared localhost. So it's a couple of reasons you might have more than one container in a pod. But you would never put your database for that application in the same pod. It would be a separate pod because it's really a different scalable unit of your application, and you would scale your front end differently to how you would scale your back end. So we'll get on and do some demos. So I'm going to, hopefully the Wi-Fi is friendly. So we're going to run this create command. So we're running kubectl create deployment. We're giving that deployment the name of hello, and we're giving it the image that we want to run. So if I do a get all, I have k alias to kubectl just for less typing. So you can see, even though I asked for a single deployment resource, I actually have 3 different resources running. And this is controllers in action. So there's a deployment controller, and that deployment controller is responsible for the full application lifecycle of my application. And part of that is managing how many replicas are running, and it does that by working with the replica set controller. And that replica set controller then manages 1 or more copies of your pod up the top there. And so that's why, even though I've only asked for a deployment, I have 3 resources, and they all work together to ensure my application is running. So I can give it a scale command and say I want 6 replicas. And if we do my get all again, we will see there's now 6 copies of my application running, or at least 6 that are starting up. And you can see it happens pretty quick, right? Most of them are already running. And you can see in my deployment, it sees there are 6 up and 6 available. And my replica set shows there's 6 up and 6 available. So if I run it again, we should see everything running, right? So we can show kind of the autocorrected behavior by picking a random pod and deleting it. Because I have a size of 6 in my desired state for my deployment, when I delete a pod, I'm basically simulating a failure, right? And so if I do a get all again, what we'll see is there are still 6 running. There's just one that's a fair bit newer. So we have that, the one at the top there is only 12 seconds old. So the replica set controller saw, for some reason, there was only 5 running when I'd asked for 6. So it span another one up, right? Because I didn't change the scale I wanted. I just deleted a pod out from under it. And so that's an example of controllers using their autocorrective behavior. I mentioned that deployments are responsible for the full application lifecycle of your application. And so I can show how that works by editing our deployment like this. So basically, you can, if you want, edit the desired state live in Kubernetes. And so that's what I'm doing here. As you can see, there's quite a lot more to my Kubernetes manifest than what I showed earlier when it's actually running. And you see an interesting thing here. There's a strategy for doing upgrades, right? So this is the defaults on how a deployment will upgrade my application. And we can force an upgrade simply by adding an environment variable. So we'll go ahead and do that if I can get my tabbing right. So that is, I've edited my desired state for my deployment. And so if I do a get all again, we'll see some changes happening. So you can see we have a bunch of pods running, but my deployment says there's 6 running. And then I have 2 replica sets now. One that's new, that says that's at 6, and one that's old, that's at 0. So what's happening is the deployment saw that I changed my desired state, and so it's created a new replica set, sized at 0, and then it scaled that one up as it scaled the old one down until the new one was at 6 and the old one was at 0. And so that's Kubernetes through the deployment controller doing a full live upgrade, rolling upgrade of my application without me having to do any real work. I haven't had to program in anything. Back when I used to write Chef, I would write hundreds of lines of Chef to try and make this happen, and it still didn't happen anywhere near this smoothly. So a lot of things that we used to do in operations with a lot of toil is now just handled by the platform. So if I run that get all again, you'll see that just the new pods are running. Yep. So that's great. I have an application running, but there's no real sign there how I should access my application, right? I want to validate my application is running. So one way I can do that as an admin of Kubernetes with kubectl access, I can do what's called a port forward. And I'll just pick a random pod and just go with that top one. And I need to give it a port 8080. So what this is doing is it is mapping localhost port 8080 into the localhost of the running pod that I've chosen. And so I can then use HTTP localhost port 8080, and I'll get a response back, and that's the environment variable that I set earlier, right? So that's clear evidence that my application is working, and the upgrade to that application when I change the environment variable, it did its job correctly. And that's great for me because I can validate my application is running, but I want to actually expose it to the outside world. I want people to be able to access it, and I don't want people to have to run kubectl commands to access my websites, right? And so I need a way to expose it, and that is quite simple using services. So I run this command, kubectl expose. I choose my deployment hello. I set a type of load balancer, and I choose ports. So load balancer port 80 should go to my application port 8080. And so with that created, I can now do a kube get service. And here is the service I created. You can see it's called hello, type load balancer, and it has this thing, a cluster IP. So that's an IP address inside of my Kubernetes cluster that will load balance for every pod that it knows about. So anything else running inside of Kubernetes can access it via that cluster IP, or it can access it via that name. Kubernetes has a DNS server built in, and so when you register a service, it registers the service's name in DNS. So anything else running in Kubernetes can simply do a curl against hello or whatever you want to do. And then you have ports. So we have this ephemeral port 30432, which Kubernetes picked out of random from free ports. And that is exposed on the external IP address of all of my worker nodes. And so what that means, if I know the IP address of a worker node and I know that port, I can now access my application from outside of the cluster. But it's still not really cool to have to give someone like a set of random IP addresses and a set of random ports. So when I set type to load balancer, the Kubernetes Cloud Controller Manager will actually spin up a load balancer in your cloud. In this case, it's Google Cloud, and will load balance to the external IPs of your nodes and to that port, because Kubernetes already knows that stuff. So it makes sense for Kubernetes to actually just manage the load balancer. And then as worker nodes fail and new ones are created, it will update the load balancer, so it's always up to date. So if I run that get service again, we should see that we have an external IP address. And so if I switch to here, I can do a HTTP of that. So that's going through the internet, hitting Google Cloud, getting load balanced into my cluster and through to my running pod. So that's pretty good, really easy to set up, really easy to get my applications exposed to the internet. And I will show you how the service knows what pods to talk to. So in your service spec, you have a selector, right? And so that selector basically tells the service to look for any pod that has that label app hello, right? And so if we go and look at our deployment, you can see we have that label of our app hello. And in the deployment, you have your pod template, which is here. And again, it has that label app hello. And so basically, any pods with that label will be load balanced by that service. And that's why when we do an upgrade of our deployment, the load balancing continues working, because as the new pods come up, they have that same label. If you wanted to, you could add an extra label for like active and not active if you wanted to look at doing like a blue-green deployment type scenario. So there's a lot of interesting, powerful things you can do combining labels and the service selectors. So that is, let me see, we got through pods, we talked through services. So when you have services, it's one load balancer per application. If you get tens or hundreds of applications running, you end up with tens or hundreds of load balancers running, and then people yell at you for spending too much money in the cloud. So you have this thing called an ingress controller. And an ingress controller adds like layer 7 routing to your services. So instead of having 10 load balancers, you just have one load balancer, and that balances into a smart proxy inside of your cluster, and that knows about these rules you've set, say, this is my host name, and if you go to /bacon, go to this service. If you go to /eggs, go to this other service. So now you can have just that one load balancer and have it load balance for multiple applications based on URL name and stuff like that. And then you can go a step further with service mesh and do interesting things like, say, send a percentage of my traffic to this service and another percentage to this other service. So there's a lot of interesting controllers that are being built on top of Kubernetes to do really interesting routing behaviors. Volumes are pretty simple. It's just a directory on disk that's mapped into your each of the pods, each of the containers in your pod. Usually shares that life cycle of your pod, so will be destroyed when your pod is destroyed. But you can use persistent volumes, and you would use them if you have data that you need to outlive a pod. And so you can tie that together with stateful sets, which are similar to a deployment, but they have an ordered startup and predictable naming. And then you get a fairly safe place that you can start running stateful applications, even databases like Cassandra or Mongo. You can also mount volumes from these things called config maps and secrets, and they are effectively key value pairs that are stored inside of Kubernetes and can be exposed to your application. And they can be exposed a couple of different ways, either environment variables or as files in a directory. So if you want to do as environment variables, you would create a config map, something like this, where you give it an explicit key and value message in hello S1T. If you wanted files in a volume, you would create it like this, in which case you would get your key is your file name and your value is the contents of that file. There are also secrets. So if you have passwords or you have something that you want to restrict a little bit, you use a secret, and you can see you can't actually read the contents of index.html anymore. It is not encrypted by default. That is base64 encoded in case you have binary secrets. It still does have some restrictions about what pods can access a secret and what worker nodes that secret is available on. And we are working on having encryption by default. It's not quite there yet. You can integrate secrets with tools like HashiCorp Vault if you need that higher level of encryption. I think I'll skip through Helm and just get straight to Spring. So I have a couple of different ways to run Spring applications and how they integrate with Kubernetes. You saw I've already run a Spring app, right? That Hello World app was a Spring app, and I didn't really do anything special, right? So just using any application, Spring or not, on Kubernetes, you get things like service discovery via DNS. You get configs via config maps that you mount in as volumes. So you get some of that stuff without having to do a lot of work. However, with Spring Cloud Kubernetes, we can eliminate extra infrastructure. So we would use Eureka, obviously, in the cloud to do service discovery. Well, Kubernetes already can handle that for you, so you can eliminate that and use Spring Cloud Kubernetes instead. You can do the ribbon-style client-side load balancing. You can do dynamic config. So instead of having to run a Spring config server, you can have Spring talk directly to config maps and secrets. It's aware of if it's running in Kubernetes or not. So you can have a Kubernetes application properties file, and that will get automatically loaded when you run an application in Kubernetes. So that way you can disable Eureka and enable Spring Cloud Kubernetes and have it function correctly in Kubernetes while still also functioning correctly outside of Kubernetes. There's also Istio and other service mesh awareness, and you can also pass in pod health indicators. So you can set your health actuator as a readiness check and a liveness check in Kubernetes, and that way Kubernetes will actually act if your application becomes unwell because it's seeing that health status. So service discovery, we can just use the defaults in Kubernetes, but if you need to do something a bit cleverer, if you want a Eureka-style service discovery, basically this is really all you need. So you have your dependency up in your POM, and then you're basically just enabling the discovery client. So fairly simple. For load balancing, client-side load balancing, obviously you have services perform load balancing for you, but if you want to do something a little bit trickier, you can enable the Spring Cloud Starter Kubernetes ribbon, and you can sort of build out an edge application that integrates with Kubernetes. This is all you need in your actual application to load balance for all of the services running in your Kubernetes namespace. So it becomes very easy to write custom edge applications or just do the client-side ribbon inside your actual application, and you don't really have to do any extra work. So that's super useful as well. So configuring your apps, obviously you can put config files in a config map or a secret or environment variables. You can also tie into Spring Cloud Starter Kubernetes config, which treats Kubernetes as a config server. And so in your application properties, you might have a list of config maps and secrets that you care about, that you want it to read from, and then your application will watch those through the Kubernetes API, and will automatically, if you have the reload actuator set up, will automatically restart your application when those config maps change. And then there's those other bits I mentioned. And then, while not specifically part of Spring Cloud Kubernetes, we have the micrometer registry Prometheus. And when you enable that in your pom.xml, it will basically expose an actuator with a set of about 150 metrics that Prometheus can scrape. And when you have Prometheus running inside of your Kubernetes cluster, it's automatically looking for any applications that are exposing that endpoint, and will automatically start collecting metrics. And then when your application stops running, it will stop collecting metrics. So you get that completely automatic metrics collection. You don't have to send in an email or a ticket to IT to have your application monitored anymore. It just happens automatically, which is super useful. And then there are some dashboards up on the Grafana website that will then let you look at your metrics. So this is kind of just your basic JVM heap, etc. And I haven't done any customization here. I've just grabbed the default dashboards, and it gets me a fair bit of information. So that's super useful as well. So I thought I might show some of this in action. So we'll change our namespace, and while that's happening, so here is an application. It was written by Ryan Baxter, I believe, for a Spring One platform talk, but I've modified it to function a little bit better with Kubernetes. So let's get rid of that. So we have three microservices and a gateway in this application. Fairly simple, and we have Jib enabled for doing builds. In one of our microservices, fashion bestseller, basically it's a RESTful endpoint that lists the best-selling items, which are just pulling from a config file, and I'll show that in a second. You can see I have Chaos Monkey enabled, so it can simulate failures, and I have my Spring Cloud Starter Kubernetes pieces and my Prometheus registry. Inside my application itself, you can see I have the refresh scope, so that's telling Spring that this part of the application can be restarted on configuration change. And you can see I'm pulling values here. So these values, this value product, can be pulled from an application properties. So I can change the list of best-selling. Obviously, you'd actually have this tied back to a database in real life or whatever, but it's just for demo purposes. So when I access this via the bestseller endpoint, I should get a JSON document with that list of best-selling products. Here is my application Kubernetes properties file. So you can see I'm enabling Spring Cloud Kubernetes and reloading. I'm enabling my restart endpoint, and I'm disabling Eureka. Obviously, I don't want Eureka and the Kubernetes service discovery happening at the same time. They will fight and will have a bad time, so I disable Eureka. Because I'm doing that in the Kubernetes profile, it will automatically get loaded if I run this in Kubernetes. If I don't, then it would keep running as Eureka by default. And then in my gateway application, it's pretty straightforward. I'm building routes for my various applications. So here's my fashion bestseller, and then I'm setting some failure fallbacks, etc. on failure. So when we're looking at this app later, if the Chaos Monkey kicks in, we'll actually see it fall back to an empty list. So we'll keep an eye out for that. That's really all you need to see there. And then we also have this sort of automatic discovery locator for the gateway, so it should also load balance for any of the other services in my Kubernetes namespace. So let's actually have a look at it. So I have this running in my Kubernetes cluster. So we have the fashion bestseller and the gateway. They're the two things we're going to look at. And I just need to grab my port forward command so I remember it. So I'm port forwarding into my gateway because I haven't got this exposed to the internet. And then from this other page, we will have a look at my bestseller endpoint. So let's grab that. So we should see, we get this response, and these values are different to the defaults that were in my app, and that is because I am using a config map as a config server. So if we look at that here, you can see you can either have straight keys and values, or if I wanted to, I could have the entire application properties as a file in here. So if I wanted to, I could do something like this. So that would be the other way of doing it, if I spelt it right. But I'm cool with just the keys and values. So I want to make a change. I've noticed that in Poland we tend to dress a little bit better than we do in the US. So I'm going to go ahead and say that we are going to have fancy pants, fancy shirt, and fancy socks. And so I'm going to save that off. And then if we look at this, we'll see it's already updated. My application has already refreshed from that config map change, and we see the new results. And we can look at our logs. So you run kubectl logs, and you can look at standard out from any of your applications running inside of your pod. So if we scroll up, we can probably find, here we can see it's detected change in the config map, reloading using the refresh strategy, and reloading like so. So we've got like very quick config change restarts, and we don't need to run a separate config server. It's just doing that directly through the Spring Cloud Kubernetes integrations. So that's a quick run through a couple of the things that Kubernetes will do. Where did I go? Here. Obviously, if you're running Spring Cloud, if you're running the Prometheus endpoint, you probably need to have Prometheus and Grafana running in your cluster. And that's where someone like me needs to come in and actually build all of the extra things around your Kubernetes cluster to enable metrics, to enable logging, to enable a CI/CD pipeline, etc. So that's my job, so that you all don't have to do it. And I'm probably going to do it multiple times, right? Because you're probably going to have more than one Kubernetes cluster. You might have one in each data center. You might have one for dev, test, prod. However it works out, chances are I need to run all of these things multiple times, which means I also need to follow modern software development practices, and I need to do CI/CD on the infrastructure the same way you'll do CI/CD on the applications. So I can use tools like Helm, and there's a tool called Helm file that gives me GitOps-style workflows. And so I have all of my kube manifests in the form of Helm charts, which basically let you template out Kubernetes manifests. And then I have a bunch of different environment repos that are specific for each one. So the different DNS names, the different IP addresses, any of the other differences, different certificates, etc. And then I have Jenkins or something like Jenkins performing actions when those change. So that allows me to perform similar. What was I saying? Oh yeah. So that allows me to manage 3, 4, 5 Kubernetes clusters and all of the extra bits required as easily as I can manage one. Right. So I'm taking things that you've all taught me over the last 10, 15 years and really getting good at applying those to the infrastructure. And that then will allow you all to have a GitOps type workflow, a Git push, have the platform, which I've built for you on top of Kubernetes, perform all of the CI/CD tasks to get your application from source up in GitHub all the way through to running in production. And I'm going to use tools like Concourse or Jenkins. Obviously, I'm going to have a container registry, so Harbor if it's in my own data center, or maybe like the GCR registry if I'm in Google. And then I'll use a tool like Spinnaker to perform the CD side of things. And then obviously Kubernetes, which I would use PKS because I work for Pivotal, but you're free to use whatever you want. So that is about all I have time for. I think I'm giving you a couple of minutes back. So thank you so much. I hope this has been useful.